Hello everyone, welcome to Electrical Pathshala 2. In this video, we will study about open loop control systems and differences between open loop and closed loop control systems. So let's start. In our previous video, we have already studied about closed loop control systems, and we know that a closed loop control system is sensitive with respect to any disturbance in its feedback path. It means that if there is any disturbance in the feedback element of a closed loop control system, then the output of the system will also get affected by that. So we can say that sensitivity of feedback element or HS is not equals to 0 for a closed loop control systems. But there are some applications in which even if the feedback elements are not working properly, or there is some disturbance in the feedback path, the output of the system doesn't get affected by that. To meet the requirements of such applications, we have a concept called open loop control systems. In open loop control systems, we say that we are removing the feedback, but it doesn't mean that we are throwing the feedback out of the system. But when we say that we are removing the feedback or eliminating the feedback, or there is no feedback, it means that we are removing this connection. And in practical system, when we say that we are removing the feedback, it means that we are disconnecting the feedback element from the controller. So now the output of the feedback element will not be given to the controller. Instead, it will be displayed by using a display, as you can see in this block diagram. So no feedback means no connection. Such systems are called as open loop control systems, and the name also suggests open the loop. As you can see that this is the loop. When we open this loop, we get our open loop control systems. But what are the advantages of opening the loop? When we open the loop, the sensitivity of feedback element or HS becomes 0. It means that the open loop control system is not sensitive to any disturbance that occurs in its feedback path. So even if there is a disturbance in the feedback element of an open loop control system, what will happen at most? This display will not work, but the output of the system will not get affected by that. So this is the advantage of opening the loop. Now, before moving forward, you should remember 2 points related to the sensitivity of an open loop control system. And those points are: first point is that sensitivity of an open loop control system due to any disturbance in its feedback element is 0, because we remove the connection. So if there is any disturbance in the feedback element of an open loop control system, the output of the system doesn't get affected by that. The second point is that sensitivity of an open loop control system with respect to any disturbance in its forward path or input is 1. It means that if there is any disturbance in the forward path or input of an open loop control system, then the output of the system will get affected by 100%, or we can say that the entire effect of disturbance will be seen on the output of the system. So in this way, we can say that in an open loop control system, the output will follow the input only if there is no disturbance in the forward path and the input of the system. So this is a condition. Therefore, the open loop control systems are also called as conditional control systems. So these are the 2 points related to the sensitivity of an open loop control systems. We will discuss these points in detail in sensitivity analysis of control systems. So on the basis of above discussion, we have wrote down some important point for an open loop control systems. So the first point is that open loop control systems are conditional control systems which are formulated under the condition that the system is not subjected to any type of disturbance in forward path, including the input. We have already discussed this point. The second point is that the system in which output of the system is not fed back to the input is called as open loop control system. And you can see in this block diagram that output of the system is not fed back to the input. Instead, it is being displayed by using a display. So such systems are called as open loop control systems. We have been told that in open loop control systems, feedback is not present, but this statement is not true, because feedback is present, but in open loop configuration, feedback is not connected to the forward path or controller. The next point is that in open loop control systems, feedback elements acts as the display of the output. As you can see that feedback element, this is your feedback mechanism, and this is acting as the display of the output. This display will show the output of the system. So our next point is that in open loop control system, control action does not depend on the output of the system because feedback is not connected to the forward path. The next point is that any physical system which does not automatically correct for any variation in its output due to change in parameters, change in environmental conditions and other disturbances is called as an open loop control system. It means that if the output of the open loop control system deviates from its desired value, then the open loop control system is not capable to bring it back to its original value. So open loop control systems are not automatic control systems. The last point is that control action and its adjustment in open loop control systems generally depends on human judgment because feedback is not there. Now we will understand the concept of open loop control system with the help of a water level control system, which we have already discussed in our previous video. So if you haven't watched it, please go and watch. So this is your water level control system which we have discussed in our previous video. So I will explain this briefly so that you can understand it better. So this is your water level control system. In this the objective of this system is to keep the water level in the tank up to a prescribed height. So in this system there is a tank which is having an inlet and an outlet, and there is a tap at the outlet, and this tap controls the outlet flow rate. So this tap can be called as control element. We have employed an automatic controller and this will open or close the tap according to the situation, and we have given a set point value to this automatic controller. This set point value is that prescribed value up to which the water should be in the tank, and this set point value is the input to this system. We have also employed a level transducer which will measure the water level in the tank at any instant of time, and that height will be your output. So this level transducer is feedback element, and this level transducer will send the information about change in water level to the automatic controller, and according to that information this automatic controller will take control action. But in this diagram you can see that this feedback element is connected to the automatic controller. That's why this is not an open loop control system. This is a closed loop control system. But if we open this loop, if we disconnect the feedback element and automatic controller, then we will get our open loop control system, which you can see in this diagram. This is your open loop control system. What we have done here, that we disconnected the level transducer from automatic controller and connected this level transducer to a display, and this display will show you the height of the water in the tank at a particular instant of time, and according to that you will take control action. So this is your water level control system as open loop control system. Now the block diagram this is the block diagram representation of water level control system. In this block diagram you can see that feedback is not connected to the forward path or controller. Instead it is connected to a display which will display the output of the system. What is the output? The height of the water level at any instant of time, and input is your set point value. So this is your forward path, and gain of the forward path is given by GS. This is your feedback path, and gain of feedback path is given by HS. Now you know that we use some general notation for specific terms. So RS is used for input, ES is used for error signal, for output we use CS, and for feedback signal we use BS. So this is the block diagram representation of water level control system. Now this block diagram can be represented by a canonical form, and you know that in canonical form we only use general notations. So these three blocks will be replaced by feedback forward path gain block GS in the canonical form, and this feedback mechanism will be replaced by feedback path gain block HS. So this is your canonical form. In this canonical form, this block is your forward path gain block GS, and this block is feedback path gain block HS. This is your input RS, error signal ES, output CS and feedback signal BS. So this is the canonical form of an open loop control system. Now this canonical form can be redrawn like this. This is your GS, this block is HS, here RS. Because feedback is not connected to the forward path, therefore this RS is equals to ES. We can write that RS is equals to ES, and here CS and BS. Now you know that feedback element generates a feedback signal which is proportional to the output. So here we can write that BS is directly proportional to CS. Now you know that GS by 1 plus GS HS is the mathematical form of a closed loop control system. Similarly, we can also write mathematical form of an open loop control system. So we will draw now the mathematical form. So this is the mathematical form of an open loop control system. GS HS. This is the mathematical form of an open loop control system. And again here you can write RS, ES and CS, BS. Here RS is equals to ES and CS, BS is directly proportional to CS. So this is the mathematical form of an open loop control system, and this form is also called as open loop mathematical form. Now if you want to draw the mathematical form with respect to actual input and actual output only, then that can be drawn like this. This is the mathematical form with respect to actual input RS and actual output CS only, RS and CS. So this block represents GS. What is this? This is your actual input and this is your actual output. Don't think that HS is not present in this diagram. HS is also present, but the value of HS is equals to 1. So we can say that gain of feedback path or HS is equals to 1 for this particular block diagram. So this is the mathematical representation of an open loop control system with respect to actual input and actual output only. Now let's talk about some other examples of an open loop control system. So the first example is traffic light system. This is the most common example of an open loop control system which we see in our daily life on a regular basis, and if you don't see that, then you have to pay the fine. So in a traffic light system, the red light, green light and yellow light have to flash for a certain amount of time. For what time these lights should flash and what should be the sequence of light is written in a program and given to the controller. Now this is a open loop control system, and you know that for an open loop control system, once the input is given, it should not be changed, and there should be no disturbance in the forward path. If these two conditions are satisfied, then for a given input you will obtain a desired output. But if you change the input, then the output of the system will also change accordingly. So suppose if you set 40 seconds for red light, then the red light will glow for 40 seconds only if the two conditions are satisfied. But if you change the input, then the output of the system will also change accordingly. Or there is some disturbance in the forward path, then also the output of the system will get affected. Now you might have seen that timers are available on the pole, which shows the time of glowing of a particular light. So these timers represents the feedback mechanism of the system. Now suppose if the mechanism which is showing the time is not working properly, then what will happen? You will not be able to see the time. It means the display will not work, but this will not affect the working of traffic light, because this is an open loop control system, and an open loop control system is not sensitive to any disturbance in the feedback mechanism. Now, why we call this traffic light system as an open loop control system? It's because once you set the timings and sequence of the lights, you cannot change it, whatever may be the actual traffic flow. For example, suppose there is very heavy traffic in one lane, so the timing of green light will not increase for that particular lane, whatever may be the situation. So that's why we say that traffic light system is an open loop control system. But if you employ a traffic flow sensor if you employ a traffic flow sensor in the traffic light system and connect it to the controller, then the same system will now become a closed loop control system. In this case, the traffic flow sensor will analyze the actual traffic flow and send the information to the controller, and according to that information, the controller can change the timings and sequence of these lights. So in this case, the system will become closed loop control system. But there is one shortcoming, that if there is any disturbance in the feedback mechanism, then not only this display but the entire system will get affected by that disturbance. The other example of open loop control system is bread toaster. So we use bread toaster to toast the bread. How bread toaster works? You put a bread inside the toaster, press it down, and exactly after a designated time, the machine will throw the bread out. But it means that for a given input, you are obtaining a desired output. But suppose you want more crispy bread, then what will you do? You will keep the bread inside the machine by pressing it with your fingers, even if the machine is trying to throw it out. So in this case, you are introducing disturbance in the forward path of the machine. And being an open loop control system, you know that the sensitivity of the machine due to any disturbance in its forward path is 1. It means that whatever disturbance you are causing in the forward path, the output of the system will get affected by the same amount. So after some time, you will see smoke coming out of the machine, and soon you will realize that not only the bread but your finger is also burnt. So I suggest you to not do such silly things. There are some other examples of open loop control systems like washing machine, ceiling fan, electric iron, and various other examples. Now, from the above discussion, 2 questions may be asked. The first question is that if an open loop control system is not sensitive to any disturbance in its feedback mechanism, then why we keep it? Why don't we throw it out of the system? Why we keep display in an open loop control system? So to understand this, we will go back to water level control system. So you remember that in this the objective of this system is to keep the water level in the tank up to 5 meters. So if you throw this mechanism out of the system, then how will you know that what is the water level in the tank at a particular instant of time? In this case, you can do 2 things. First, you can use your sixth sense, means you can assume, or second, that you jump into the tank with a scale and measure it by yourself. But both ways are not practical. That's why we keep this display, we keep this feedback mechanism, so that we can take control action. So that's why to know whether for a given input a desired output is obtained or not, we keep the display or feedback mechanism in an open loop control systems. Now the second question can be asked, that why we call open loop systems as control system? Because we know that open loop systems are conditional control systems, and it means that in open loop systems, if input is given, we cannot change the input, because if we change the input, the output will also change accordingly. And the second thing is that in open loop system, if the output of the system deviates from its desired value, we cannot bring it back. Then why we refer open loop systems as control systems? Because irrespective of any condition, if for a given input you are obtaining a desired output, then that system is called as controlled system. And you know that in open loop system, for a given input, it's not like that we are obtaining any random output. For a given input, we obtain desired output only. That's why we call open loop systems as open loop control systems. Now, as we know that open loop systems are conditional control systems, therefore performance analysis is not applicable to open loop control system. Now, what is performance analysis? What are the effect of disturbance on the output of the system? Is whether the system is stable or not? Time response analysis, frequency response analysis. These are the performance analysis. And because open loop control systems are conditional control systems, performance analysis is not applicable to open loop control system. So in this subject, from first to last chapter, whenever we do performance analysis, it will only be for closed loop control systems. Now suppose a question is asked like this in exam, that the transfer function of a system is s by s plus 2 and so on. Now in this question, what will you understand by this word system? This system is an open loop control system or closed loop control system. So whenever a question is asked like this and there is a word system, then this word system will always refer closed loop control system. So you should remember that. And if the examiner wants to ask about open loop control system, then he will specifically mention that in the question. Now this was all about your open loop control system. Now we will talk about the differences between an open loop and closed loop control system. So the first difference is that in open loop control system, control action is independent of the output, and in closed loop control system, control action depends on the output of the system. This is because in this system feedback is not connected, and in closed loop system feedback is connected to the forward path. The second difference is open loop control systems are very sensitive to any disturbance in the forward path. We know that the sensitivity of an open loop control system to any disturbance in forward path is 1. But closed loop systems are less sensitive to disturbances in the forward path. Next difference is sensitivity of open loop control system due to any disturbance in the feedback element is equals to 0. But sensitivity of closed loop control system due to any disturbance in feedback element is not equals to 0. Next point is the system cannot automatically correct for variation in their output. Open loop system can't correct, but closed loop systems has the ability to automatically correct for any variation in their output. This is also because the feedback connection of the feedback to the forward path. The next point is that feedback is not connected to the forward path or controller, but in closed loop systems feedback is connected to the forward path or controller. Next difference is number of components used in this system are less, so they are simple in design and cheap. In open loop control system, less number of components are used, therefore design is simple and they are cheap also. But in closed loop control systems, more number of components are used, so they are complex in design and costly also. So in open loop system, overall gain remains same. What was the overall gain of an open loop control system? GS. So this remains same, but what was the overall gain in closed loop control system? GS by 1 plus GS HS. So in closed loop systems, overall gain is reduced due to feedback. You can see here the overall gain is GS, here GS by 1 plus GS. So the overall gain is reduced by this factor. Next point is these are unreliable and inaccurate systems because feedback is not connected, but closed loop systems are reliable and accurate system. Next point is performance analysis is not applicable, and here performance analysis is applicable. Next point is stability is not a major problem in open loop control system, but stability is a major problem in closed loop control system because this system is sensitive with respect to forward path as well as feedback path elements. Now the last point is that installation is not complicated because less number of components are used, but here installation is complicated. So these were the differences between an open loop and closed loop control system. So this is all about this video. If you have any problem regarding any topic, then please ask in the comment box. If you like the video, then please hit the like button, and if you want this material in written, then please go to our website electricalpathshala.com. For Hindi content, go to our other channel Electrical Pathshala. So thank you, signing off.